Welcome back to the second video on finite differences. In this case, we're going to look at the cubic sequences. So we'll start it out with the general term a sub n is equal to an cubed plus bn squared plus cn plus d. In the first video, you saw how I worked with a quadratic, so we'll do the same thing with the cubic. A sub 1. Then, by plugging a 1 in for each of those n terms, a plus b plus c plus d. I'm going to do this quickly because I did it in the last video already, so we'll just work this out. In a sub 2, plugging a 2 in for n, we've got 8a plus 4b plus 2c plus d. A sub 3, 27a plus 9b plus 3c plus d. And then finally, we'll just do a sub 4 to give us the finite differences we're looking for. So 64a plus 16b plus 4c plus d. And then we'll write in our finite differences here. So in the first case, again, we're subtracting upwards. So this is going to end up with 7a plus 3b plus c. In the second one, we're looking at 19a plus 5b plus c, again, subtracting upward. In the third one, this one's a little trickier, 37a plus 7b plus c. One more should do the trick here. In this case, subtracting upward, 12a plus 2b, and in the next case, 18a plus 2b. So I guess we have to go to that last one there, 6a. Okay, notice again, when this is what we were looking at in the last part, you've got this first row that tells us all the answers we're looking for. And that's what we want to find. I'll come back to this slide in just a second. Let's try this with an actual example. So in this case, here are our numbers, and we'll do the finite differences below. So here's the first one. We're going to go -1 because we actually subtract there. This one is plus 13. Looks like 39. Did I do that right? Looks like it. And then this one is 77. Looks like there. Okay, let's go to the next level here. This is plus 14. And then this one is going to be plus 26. This one is going to be plus 38. And hopefully by that next one, we should get that constant. So this is going to be plus 12. And this is going to be plus 12. And so we're happy because we know that we've got a cubic going here. So finally, we see this part. And I just want to point out that we're doing something vertically here that we just did horizontally in the last problem. So this guy is the one that is 6a. So already I'm able to build my cubic. So a sub n. My a term is going to be 2, since 6a is equal to 12. So a is equal to 2. Okay, and then I go to the next term, this one here. And if you recall from the last one, you're going to need to have your notes next to you for this. That's going to be 12a plus 12a plus 2b. So going back to here, this is going to be 12a plus 2b. And since a is equal to 2, this is going to be 24 plus 2b equals 14, or 2b equals -10, b equals -5. So I'll put that down as the next part. So let's start. Our sequence is going to be 2n cubed minus 5n squared. That's the a and the b. Going back to the first part here again. Now we're going to start with this part, 7a plus 3b plus c. I'll do it up here, 7a plus 3b plus c. But I already know that that number is this value here. So that's what I'm looking for. But I already know what a is. A is 2. So 7 times 2 is 14. And I already know that b is -5. So that's going to be -15 plus c equals -1. So -1 plus c equals -1. And so c equals 0. So there is no n term. In the last part here, this number 1 is simply a plus b plus c plus d equals 1. So we know that a is 2, b is 5, c is 0, plus the d, and that should equal the number 1. So in this case, the d is going to equal 4, it looks like. It's plus 4. So I'll write that here, plus 4. Now you can always check your answer by just substituting in a 1, a 2, let n equal 1, n equal, let n equal 2, 3, and 4, etc. And you should come up with those sequence values above. It's a good way to check your answer. Okay, the next part is what happens when we have to do multiple tasks. So this is where the thinking gets a little bit crazy. It says find the general term or nth term for this sequence. And notice that there's a little bit of a mess here because some of these are fractions and some of them aren't. So we have to look for some sort of pattern, and I sense that there's a pattern right about here. 5, 3, 7. So I'm looking for clues, and that's one of them. That they're almost in sequence, but you could imagine this to be, instead of 3 over 29, you could imagine that being a 6 over 58. And if you did that, then you would end up with a 5 over 22, and you would end up with a 7 over 118. Now we've got a 5, 6, 7. The question is, do these other two terms fit into that? So the number 1 then would have to be 4 over 4. And then the negative 3 halves does fit into that if you turn that negative into the denominator. So notice we have 3, 4, 5, 6 in the top. So this would be our a sub n, and it's going on forever there. The question is, what is this denominator? So first of all, the numerator is pretty simple. It looks like it's just just starting out, that's going to be an n plus 2. So this is our first term. Let me write these in for you here. This is our first term. This is our second term. This is our third term, fourth, fifth, etc. And so our first term has a 3 in the top. Second term has a 4 in the top. So our numerator is n plus 2. The tricky part is, what is this denominator? It could be quadratic, it could be cubic, we don't know. So what we're going to do is just work over here, negative 2, 4, 22, 58. I'll do the first 4 for a second to see if it comes out quadratic. This will be plus 6 here. This is going to be plus 18. The next one is going to be plus 36, it looks like. Now we've got plus 12, and we've got plus 28, I believe. I think I did that right. I guess I'm going to have to go one more step and see if this comes out cubic. That would be plus 60. And so we end up with a, oh, excuse me, I think I have an 18 here. I think I made a mistake right there. 18 plus 18 is 36. So sorry about that. That's there. And then this one comes out to be plus 24. All right, plus 6 and plus 6. So there we've got our constant. That makes us happy because we know now that this is cubic. I'm not going to go through the whole process, but you'd be able to isolate then from these 4 terms, the negative 2, the 6, the 12, and the 6, what the 4 values are for A, B, C, and D. So that denominator, we'll call it D sub n, is equal to, and keep in mind that this 6 represents 6a. So a, of course, is going to be 1. So it's just going to be n cubed, dot, 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 and you're going to have to fill in the rest of those just like the last example. Go back through your back substitution, and you should find the values that go in there. Again, you can check it when you're done. The last problem is using finite differences to find the next term in the sequence. This is kind of fun to do because it gives us an option that we can figure out what this next term is without trying to muscle through it. Instead, we simply put the numbers out, 0, 3, negative 4, negative 9, and 0. And then after doing these finite differences, we're going to go backwards and work to the next term. So the first one is going to be a 3. This is negative 7. This is negative 5. And this is positive 9. And let's continue on. This would be then negative 4. Oh, excuse me, that's not right. That negative 10, it looks like. Negative 10. And this is 2. Boy, this is tricky with these positives and negatives. And this is 14. And then the next one is plus 12. And this one is plus 12. Okay, so we did identify that it's cubic. And there's constants here. So now what we're going to do is we're going to back this up. And we know now that whatever's that next number, so let's put it right here. We know that 0 and that one, and these two, and we're going to start at the bottom by putting a 12 in there because that has to be constant. So if that's the case, then we can add 12 to 14, and that would be 26. And then in the next case, 9 plus the 26 is giving us a 35, and then 0 plus 35 is 35. So the next number is going to be 35 by working that up in reverse. Let me just double check that. So we end up here with a 35, and then 9 to 35 is 26, and 14 to 26 is 12, and that makes us happy because it works in with our cubic. So that should get you started on that second half of the worksheet. Good luck completing all of those for your optional assignment.